form is this is our ocean, and here we have the mountains, surfaces, then we have some surface water. Now here this is our land, and here some is open water, that is it can be from a water surface, can be form of a lake. Here we have some trees, so from oceans we have evaporation, and in case of the plants this is transpiration, and from the surface water evaporation will be there, and evaporation can be from soil, from reservoirs, and all these will form this all will combine the condensation, clouds will be formed, and it will result in the precipitation. The form in which it will back to the earth surface. And it can also precipitation on the land surface. This is our hydrological cycle. So there are the different methods of evaporation. It can be from plants. In case of the plant, it will be known as the transpiration, surface water, running water, lakes, rivers, reservoirs, all these will form condensation, and it will result into the precipitation to the oceans and on the land surface. So this is our continent. Here we have the land. So the external part of the continents is in the form of the continental shelf, continental slope, and the continental rise. So these are the extension part of the continents. So the continental shelf have a minute angle, that is between a 1 to 3 degree angle, and they have a gradual slope. In case of the continental slope, there is a deep slope, and where it will like a vertical flow of the water, and it will consist sediments will flow fast from here, and there when the surface there deposition will be happen. So there it will its slope get slightly rise than the surrounding area, so it will known as the continental rise. And then we have the trenches when the two plates will one will subduct and heavier plate will subduct and the lighter plate will move or float over the heavier one, so it will form the trenches. And then we have the planes. So these are the different type of the form of the oceanic surface we have. Continental shelf. Continental shelf is the extended version of the each continent occupied by the relatively shallow seas and the gulfs. It is shallow part of the ocean. So the continental shelf is a shallow part of the ocean. On average gradient of 1 degree or even less, approximately 1 degree gradient it have. The shell typically ends at a very steep slope known as the shelf break. The width of the continental shelves vary from ocean to another. The average width of the continental shelf is about 80 kilometers. The shelves are almost absent and very long along the same margins like the coast of the Chile, west coast of Sumatra. On the contrary, the Siberian shelf of the Arctic Ocean is the largest in the world, stretches over 1500 kilometers in the width. The depth of the shelves also vary. It may be shallow as 30 meters in some areas, while it will the areas as deep as 600 meters. So the continental shelves are covered with a variable thickness of the sediments brought down the rivers, glaciers, winds from the land and distributaries by the waves, currents. Massive sediment deposit received over a long of the time of the continental shelf become the source of the fossil fuels. So in case of the continental shelf, so we will look upon this diagram. So this area is known as the continental shelf. Then we have the continental slope. Then we have the continental rise, continental shelf, continental slope. Then we have the continental rise. So the continental shelf is the submerged part. It is because of the submergence of the some boundaries, erosion by the waves, deposition of the rivers, and the gradient here is 1 degree or the less. Shallow sea of the gulfs will be there, and average width is approximate 70 kilometers and adds at the steep slope of the shelf break. So we can define it. So continental shelf is submerged part, and it is formed due to can be because of the submergence of boundaries, and it can be because of the erosion of the waves, and it can also be because of the deposition of rivers. Continental shelf have the gradient of 1 degree or less than this. Next we have it is shallow seas or the gulfs. And average width is approximate 70 degree. and it ends at the steep slope. So at shelf break. So the shelf region is the transition zone between the freshwater runoff from the land and more saline water of the sea. So continental shelf is the transition zone. Is the transition zone between freshwater runoff from land and more saline water of the seas. Freshwater runoff of the land and the saline water of seas or the oceans. So it will have some features. Continental shelf is provide the fishing grounds, and it is the source of the minerals and the sand, and it is also a source of the petroleum and the natural gases. So it is the continental shelf part of the this. And due to the limited depth, the ocean currents usually run parallel to the shore of this region, and the presence of the shallow water over the shelf enables the sunlight to penetrate, encouraging the growth of the microscopic plants and the animals, that is the planktons. These planktons are the food for the fish in case of the continental shelf. So it will encourage the growth of the planktons. Next we have the continental slope. The continental slope connects the continental shelf and the ocean basins. It begins where the bottom of the continental shelf sharply drops off into a steep slope. So continental slope is having a steep slope. The gradient of the slope region varies from 2 to 5 degree, and the depth of the slope region varies from 200 to 3000 meters. The slope boundary indicates the end of the continental. Canyon trenches are observed in this region. So in case of the continental slope, this area is known as the continental slope. So we can define the continental slope. So the continental slope is the zone of deep slope having the gradient 2 to 5 degree, and its depth varying from 200 meter to 3000 meter. And here we observe the canyons and trenches. So at the seaboard ends these canyons, large amount of the sediments are deposited and spread out in a fan-like manner. So it will form the continental rise. Next we have the continental rise. Continental rise is not defined. First we have done continental shelf, then we have the continental slope, then we have the continental rise. So continental rise So continental slope loses its steepness with the depth, and when it reaches to the level between 0.5 to 1 degree, the slope is referred to as the continental rise. So here the level is between 0.5 to 1 degree. The slope is referred as the continental rise. The continental rise becomes virtually flat with the increasing depth, and it merges with the abyssal plains. Then it will merge with abyssal plains. So this is the continental shelf. Then we have continental slope, and then there is a little rise. So this area is known as the continental rise. So till here we have done here we have the land surface. The river will flow in this direction. There is a gradual slope. That is, the sea level had to be this. So this area is known as the continental shelf. Here we have the gradual slope. So here we will receive the more sun rays. This area will receive more sunlight. If this area receives the more sunlight, and here will be more insolation, and in this area phytoplanktons will be more. It will be beneficial for the phytoplanktons, and this area receives the most of the sunlight. So this is known, the area is known as the photic zone. The area which receives the maximum sunlight, this is known as the photic zone. So it will be good for the fishing. And the Doggers Bank is near the British Isles is also there, and mangrove forest, also fossil fuels for the fossil fuels. And after that, this is the land surface, this is the continental rise, then we have the continental slope. This area is known as the continental slope. So in this area, continental slope is of having granitic nature. So here we have the more sediments. And the sediments will deposit here. So it will some rise here, sediments deposit. This area is known as the continental rise. Next we have the deep sea plains. Deep sea plains are gently sloped areas of the deep basins. These are the flattest and smoothest region in the world. The depth vary from 3,000 to 6,000 meters. These plains are covered with the fine grained sediments like the clay and the silts. Next we have the deep sea plains. Deep sea plains are nothing but the abyssal plains. These are known as the deep sea plains. Now in case of the deep sea plains or the abyssal plains, it will start beyond the continental rise. They are formed by the accumulation of the sediments on the seafloor. So the sediments will be deposited and on the seafloor. And it will be superimposed on this will a very flat plain are many rugged reef features such as the seamounts, gyres, atolls, silts, and the trenches will be in these plains. So in the abyssal plains we have the trenches, we have gyres, we have seamounts, atolls, silts, etc. So we have the continental rise, then we have the continental slope, then we have the abyssal plain. Now in case of the abyssal plains, here deposition of marine sediments, deposition is in the continental rise sediments, and we also have salt particles, and abyssal plains have the flattest topography of oceans. So deep sea plains have a gentle slope areas in the ocean basins. So abyssal plains are the part of oceans. Continental slope rise are the extended part of the continents. So these are the flattest and the smoothest region in the world. Depth vary from 3,000 meter to 6,000 meter. And the plains are covered with the fine granite sediments like the clay and silt. Abyssal plains we have the fine clay and silts. Oceanic deeps or the trenches. These areas are the deepest part of the ocean. The trenches are relatively steep-sided, narrowed basin. These are from 3 to 5 kilometer deeper than the surrounding ocean floor. They occur on the basis of the continental slope and alongside islands, arches, and are associated with the active volcanoes and are strong earthquakes. That is why they are very significant in the study of the plate movement, as are there 57 deep have been explored so far, out of which 32 are in the Pacific Ocean, 19 in the Atlantic Ocean, and 6 in the Indian Ocean. So next we have the deep trenches. We have ocean, deep, and trenches. So it is the deepest part of oceans. And here we have the convergence of oceanic continents plates. When the plate will converge, then the lighter plate will be uplifted by the heavier one, and there will be a subject. If this is the oceanic plate, and the second we have the continental plate. Oceanic plate is heavier than the continental plate, so the oceanic plate will subduct, and here we have the continental plate. So it will get melted, then it will rise, and this process will happen. So there will form the volcanoes, and these are known as the trenches. They are known as trenches. So it will occur on the base of the continental slope. Base of continental slope and alongside the islands. So this will rise. Again this will subtract. This part will more subtract. This will again rise. So here we see the formation of the volcanoes. And trenches will be in the subduction zone. This is the subduction zone. So trenches are the sites of the subduction zone in the plate tectonics. That is, they are the tectonic origin and formed during the convergence of the plates. So this convergence can be of the oceanic convergence and oceanic continental convergence. So if there is both are the oceanic plates, then the which one is the heavier, that is the more larger plate will get subducted. So the trenches are formed alongside the edges of the deep sea plains, and it will run parallel to the fold mountains, so the island chains that will be formed. And the Mariana Trench is the deepest trench with a depth of 35,000 feet. The next we have these minor relief features. Apart from the above mentioned major relief feature of the ocean floor, some minor features, significant feature predominant in the different part of the oceans. Mid-oceanic ridges. How mid-oceanic ridges will form? So mid-oceanic region is composed of the two chains of the mountains separated by a large depression. The mountain regions can have a peak as high 2,500 meters, and some have even reached above the ocean surfaces. Island as part of the mid-Atlantic region is an example. So in case of the mid-oceanic regions, these will be formed when the plate gets diverged. So when this plate get diverged, the lava come from on the surface, and this plate might diverge again and again. So it will form the ridges here. So mid-oceanic ridges are elevated steep side elevation of the sea floor. They are also known as the oceanic mountain ranges. So they are the narrow elongated mountain ranges rise from the abyssal plains, and tectonic origin, evidence of the plate tectonic theory, and because it will form the mid-oceanic ridges, and these are the largest mountain system in the oceans. The Atlantic ridge is about 16,000 kilometers long, and it is the largest ridge in the world. This is the largest mountain system, that is it is Atlantic ridge. This is the Atlantic ridge, which is about 6,000 kilometers long, and it is the longest ridge in the world. The peak of the some ridges may rise above the sea level to form the islands. Sea mounts. It is the mountain with the pointed summits rising from the sea floor that does not reach the surface of the ocean. Sea mounts are the volcanic in origin. It can be from this to told. The Emperor Sea Mount, an extension of the Hawaiian Islands in the Pacific Ocean, is a good example. So in case of the sea mounts, so sea mounts will not reach upon the surface of the sea. Pointed summit from the seafloor do not reach on the surface, and they are having the volcanic in origin. So these are known as the seamounts. If these will rise upon a period of time, so it will lead to the formation of the volcanic island, that is above the sea surface. So it will form the volcanic islands, and if there is a flat surface on the sea surface, then it will be known as the marine erosion. And if it is flattened surface in the sea surface, that is not reached up to the sea surface, that is eroded by the waves, currents, so it will known as the gyots. So submarine canyons are the deep valleys are comparable to the great canyons in the Colorado River. They are sometimes found cutting across the continental shelf, and the slope often extended from the mouth of the large river. The Hudson Canyon is the best known canyon in the world. So submarine canyons are the deep valleys. Some of them are can be compared with the Great Canyon of the Colorado River. They are sometimes found cutting across the continental shelves, and the slopes often extending from the mouth of the large rivers. That is this. So it will cut the surface continental shelf and the continental slope, and then it will be starting flowing. So it will form the canyons. So this is known as the submarine canyons. Next we have the guyers. It is the flat top seamounts. So it is a form of the seamounts having the flat top. They show evidence of the gradual subsidence through the stages, and it will become the flat topped submerged mountains. So some activities have happened there. So it will flatten the top surface of the dead submerged mountains. So it is estimated that more than 10,000 seamounts and the guyers existed in the Pacific Ocean alone. So in case of the Pacific Ocean, there is more than 10,000 seamounts and the gyres existed. Atolls. They are a low island formed on the tropical oceans consisting of the coral reefs surrounding a central depression. It may be a part of the sea, lagoon, and sometimes from enclosing a water of a fresh, brackish, or the highly saline water. So atolls are the low islands which are mostly found on the tropical oceans. It will consist of the coral reefs surrounded by some depressions. So they are a part of the sea in that is a lagoon, and sometimes it will also from a enclosing fresh water body, and it can be from a brackish water body, and it can be also from the highly saline water. So having so this in this we have the flattened surface below the sea surface is known as the gyres, and having the peak rises, then it will be known as the sea mounts, and if it will be above the sea level surface, then it will be known as formation of the land. So this is known as the volcanic islands. This is the whole oceanic relief features. Temperature of the ocean water. How the temperature of the ocean water bodies differ from place to place. This section deals with the variation of the temperature in the various oceans. Oceans water get heated up by the solar energy just as the land. So incoming solar radiation will heat up the ocean surface just as like the land surface. So the process of the heating and the cooling of the ocean water is slower than the land because of the water have a high specific because of the specific heat of the water is high as compared to the land, so it will take time to warm and it will take time to cool, but in case of the land it will get cooled and heated fastly. So the factor affecting the temperature distribution of the ocean water, first one is the latitude, then the unequal distribution of the land and the water, and the prevailing winds and the ocean currents. So these are the factors which will lead the differences in the temperature of the water bodies. So in case of the equator, how latitude will, the temperature of the surface water decreases from equator towards the poles because the amount of the insolation decreases forward. So in case of the first factor which will affect the temperature distribution is latitude. How latitude will define, that is equator to poles. So in poleward areas, the temperature of ocean water ocean water reduces. So it have two exceptions. First one is at equator. How? The temperature at equator, that is 0 degree, is not maximum. So in case of the equator, the temperature is not maximum. It can be because of convectional rainfall, and there is the formation of the cumulonimbus cloud, having the higher albedo, so it will reflect more the incoming solar radiations. And the third factor which will affect is the upwelling. So in case of the equator, the maximum temperature is not 0 here because the convectional rainfall, that is the 4 o'clock rainfall, so in case of the equator, the incoming solar radiations are more, so here the evaporation will be more, so it will form the clouds. And it on the equator we have the 4 o'clock daily rainfall, so because of this and the formation of the clouds and the upwelling of the winds, so it will not lead to the maximum temperature on the equator. So where is the maximum temperature? So maximum temperature we found is between the 25 degree to 35 degree latitude. How we will find here is because in this area it is the high pressure area. In this case we have the sinking air, and in this area no clouds will form because of sinking air, it will not form the clouds. And so the insolation here will be more because of there is no cloud who will reflect back, and it is the sinking air, so it will trap the more the insulations, and there is no daily rainfall, so the maximum temperature is observed at the 25 degree to 35 degree latitudes. Next we have the unequal distribution of the land and the water. Second factor is the unequal distribution of land and water. How it will affect the distribution of the temperature? Now suppose this is here we have the land surface, here also we have the land surface, here we have the land surface, and here we consist of the oceans, that is any water body. It can be lake, it can be anything in case of the tropics. So here the temperature of the land will be high as compared to the sea. So the water in the surrounding area, there is a movement, there is a ocean currents in this water, but that is that in case of the that enclosed sea or the lake, there is the no movement of the oceanic currents, prevailing winds, not will happen. So this area will have temperature slightly less than the surrounding area. So this will also affect. So here there is a no mixing of the water. This is shown. So there is no mixing of water. If there, it will be slightly less. So example of this we have is the Red Sea, Mediterranean Sea. They are partially enclosed sea, so they will not get mixed up with the surrounding water. And similarly, in case of the polar areas, here we have the land surface, here we have the land surface, here we have the land surface. So similarly, here will be not good mixing, and here we have the water. So here is also not a good mixing of water. This water will have no, the oceanic current will not form. If form, there will little, it will not mix up with the surrounding water. And here we have the lands have the low temperature as compared to the oceans, because land will get cooled up first, and it will also affect the surrounding area. The water, that is the unclosed sea here, will not mix up with the surrounding water. So this is also affect the distribution, the temperature. Third factor we have oceanic currents. In case of the warm current, having the warmer water, we have seen the example of the North Adriatic drift current, that is warm. So in New York, this will flow like this, and here we have UK, Norway, Berlin, UK area. So the area having the Norway and the UK will have the same degree of the temperature, instead of having the different latitudes. So it will, because the North Atlantic drift current will flow from the New York to the UK. So it will avail the temperature will raise in that surrounding area. So this will affect the. And similarly, in case of the here we have the Gulf of Alaska. Here we have Alaska warm current. Instead of having the temperature very less, the Alaska warm current will raise up the temperature of that area. Similarly, we have the cold currents. Example is having the Labrador Sea. Here we have the Labrador cold current. So it will raise the temperature, so it will uh, uh, down the temperature than the surrounding area. Prevailing wind. The wind flow from the land toward the ocean drive the warm surface water away from the coast, resulting in the welling of the cold water below this. It will result in the longitudinal variation of the temperature contrary to this onshore wind available. So now in case of the, suppose here we have the equator. And the warm current will flow in this direction. So what it will do? It will drag the warm water. A welling wind will bring the warm water with them, and here upper layer is get removed. So here we have the rest, we have the cold water. So here the prevailing wind also affect the distribution of the temperature. So it will above the cold water below this, and will drive the warm surface water from the coast of the, resulting the welling cold water below this. Oceanic currents. Warm ocean currents raise the temperature in the cold areas, while the cold current decreases the temperature in the warm areas. Gulf Stream warm current raises the temperature near the eastern coast of the North America and the west coast of the European, while the Labrador current, that is the cold current, lower the temperature near the northeast coast of the North America. We have done this. Horizontal and the vertical distribution of the temperature. The temperature depth profile for the ocean water shows how the temperature decreases with increase in the depth. So as the depth of the is increasing, the temperature will start decreasing. The profile shows the boundary region between the surface water of the ocean and the deeper layers. The boundary usually begins with the around 100 to 400 meters below the sea surface and extends the several hundred of the meter downwards. This boundary region is for a rapid decrease in the temperature. This is known as thermocline. So what a thermocline is, this is the diagram here. So in this area we have seen a gradual change in the temperature. Here we have temperature and here we have the depth. So what is this, that there is slightly, then there is a decline, and then there is this. The layer where the temperatures decrease speedily, this layer is known as a thermocline layer, and it is between 500 meter to 1 kilometer. Now here, if we have the temperature on the surface of the sea is around 15 to 25 degrees Celsius. So first there is a slightly decrease in the temperature. First there is a slightly decrease in the temperature, and up till the 300 to 500 meters of the height, and after that there is a rapid decline in the temperature till 1 kilometer of the depth. So this layer is known as the thermocline layer, and below the thermocline layer deep water will start. And this is the surface water. So thermocline is the layer, it will separate the surface and deep water. So here the temperature will start sinking. So this is the general graph. This is general graph. But in case of the polar areas having the 0 degree temperature, so it will like this. So this will represent poles. So in case of the polars, the temperature is 0 degree Celsius. So in the surface water, the temperature will increases, and till thermocline layer, the temperature will start increasing, and after that there is a constant temperature. We have the constant temperature, that is 3 to 4 degrees Celsius. Either it is in the poles or in the tropical areas. Below the depth of the 1 kilometer areas, the temperature will have the 3 to 4 degrees Celsius. Now similarly, so the zone of the temperature, and that is why, so this is the thermocline layer. So it is the zone of contrasting. So it is the zone of the contrasting temperature, and that is why thermocline layer are best. So this is the zone of the contrasting temperature, and that is why the thermocline layer are the best developed in summers of tropical regions. In tropical regions. So thermocline layer is the layer that separates the surface and the deep water. So if we have more evaporation will be high. This will imply salinity will be high. And if the precipitation is more, then the salinity will be less. And the second is the fresh flow water. If the fresh flow of the water, so what will it do? rivers will add water. If rivers will add the water, so the salinity will be get reduces. And the third is the melting of the ice. In case of the melting of the ice, since my ice is consists of the fresh water, so when the ice will start melt, fresh water will be added. If the fresh water will be added, then the salinity will get reduced. And fourth, in case of the oceanic currents, so in case of the oceanic currents, when we have the example of the Black Sea, and second we have the example of the Mediterranean Sea. In case of the Mediterranean Sea, evaporation is more and less rivers flow. So there is the less addition of fresh water. So here we have the salinity will be more, no fresh water will be added. And in case of the Black Sea, more rivers drain it. Example is Don River, Danube River, and we have the Dniester River. That is, they will get they are adding water, adding of fresh water, so it will get salinity will be get reduced. So how will the salinity of the water get affected is, if there is evaporation is more evaporation, it will add salinity will be more. If the precipitation is more precipitation, then the salinity will get reduced. And fresh water more added, salinity get reduced. And melting of ice, glaciers, salinity will get reduced. And oceanic currents, depends upon the location, that is adding or. In case of the Black Sea, salinity will be less, and in case of the Mediterranean Sea, salinity will be high. So these are the factors responsible for the having the differential of the salinity in the ocean.